Hi everyone, Mike here from Bikes by Mike with another cycling related video. Today I'm reviewing 3 of the most popular spoke tensiometers on the market today. I'll give you my own impression of what I like and don't like about each of these measuring tools, but I'll also objectively test for the amount of measurement error. While some of the results were expected, others were really surprising. Okay, let's get to it. In today's video, I'll start off with a brief overview of each of the 3 spoke tensiometers I'll be testing today. I'll provide the key specs on each, explain how each works, and tell you what I like and dislike about them from a design and quality of build perspective. Next, I'll explain the 3 factors that contribute to instrumental measurement error and which one I chose to test for. I'll then run the test for all 3 tensiometers and show you the results. Last is my recommendation and final thoughts. Before I get to testing the amount of measurement error in each of the 3 spoke tensiometers, I'll give you a brief overview of all of them. The first one is the one most commonly used by home mechanics because it is relatively inexpensive and it's been around for years. It's the Park Tool TM-1. It's priced at $104.95 US or $144 Canadian. It has a spring actuated lever with analog gauge. Park Tool do not publish performance specs, so the error range is unknown. The design is quite simple. It has 2 fixed pegs and 1 movable spring-loaded peg that sits between the other 2. There's a mechanical gauge at the top numbered between 0 and 50, which measures spoke deflection. You simply clamp it onto the spoke and read the number. While the simple design is appealing, I do have a couple issues with its design. First, as compared to the other 2 spoke tensiometers, how quickly and how precisely you clamp the tool onto the spoke seems to impact the reading. So you don't want to fiddle with it too much, and you want to make sure to release the spring tension the same way for each spoke. The other major disadvantage is the reading error that is common to all analog gauges. But this one in particular I find very difficult to read. If you want to translate the deflection to a more informative measure like spoke tension, Park Tool does provide conversion charts for a variety of different spoke styles and sizes. Now, I'm not a fan of these types of conversion charts for several reasons. Often these charts won't be available for your specific model of tension meter, or the chart provided won't have the model of spoke you're looking for. Even if your conversion chart has the proper dimension of spoke you're looking for, say a steel round with 1.8 millimeter diameter, the spoke properties do vary by brand, which can produce very different deflection readings. You can even get spoke variation differences among different batches of the same make and model of spoke. That is why the only truly accurate way to get spoke tension readings is to create your own conversion charts by using a spoke tension calibration jig. Check out my earlier video where I demoed the jig I built myself. My second spoke tensiometer is the ZTTO TC02 model, currently listed for sale for $52 Canadian or $38 US on AliExpress. It has a spring actuated lever with a digital gauge. The gauge has an advertised accuracy of 0.01 millimeters, which is very good and identical to the accuracy in the gauge used in the Wheel Fanatyk spoke tensiometer. Similar to the Park Tool, it has 2 fixed pegs and 1 movable one. You simply clamp the spoke across the 3 pegs and record the reading on the digital gauge. It is well constructed and feels sturdy. The biggest advantage it has over the Park Tool is the digital gauge eliminates user reading error, which is nice. However, there is, in my opinion, one major flaw to its design. It relates to the bolt that connects the lever to the main body fitted with the gauge. While they have used a roller thrust bearing to attempt to remove friction in the moving lever, there is still noticeable friction which can impact the accuracy, reliability, and consistency of your readings. If the torque on the bolt doesn't change over time, it won't be as much of a problem. But if the bolt does loosen up, as is likely to happen, it will impact your readings. This is the reading I got measuring spoke tension without adjusting the bolt. And now this is the new reading I got having very slightly tightened the lever bolt. So if you change the amount of friction on the lever assembly, you will get different deflection readings, which won't get you consistent or reliable results. It's something you need to be aware of if using this tension meter. My third and last spoke tensiometer eliminates all the issues with the previous 2 I just covered, as it is very cleverly designed. The Wheel Fanatyk Tensiometer comes in an analog dial version as well as one of the two digital gauge options. My version sells for $265 US or $363 Canadian, direct from Wheel Fanatyks. It has a spring-actuated palm slider with a digital gauge accurate to within 0.01 millimeters. Similar to the two I just showed you, this tool also uses a 3-peg design, with the center one providing the deflection reading. However, where the previous two tools use a lever design to articulate the center peg, this one has a perpendicular slider that sits in your palm, using significantly less spring force. Beyond being ergonomically more comfortable than the other two to use, it also performs much better. This design comes from the late Job Brandt, a highly respected engineer both within and outside the wheel building community. This superior design, in combination with the use of premium quality components, is said to produce more accurate and reliable tension readings. It does this by addressing shortcomings commonly found in less expensive spoke tension meters. There are three types of instrument measurement errors that come into play when talking about spoke tension meters, or any other measuring device for that matter. They are accuracy, precision, and reliability. Let me explain each, and then I'll tell you which one I targeted for my testing. Accuracy refers to how closely a measured value is from the true value. Basically, how closely you come to the correct value. Precision relates to how closely a set of measurements are clustered around each other. Precision is independent of accuracy. Finally, reliability encompasses both accuracy and precision and relates to the ability to replicate the measurements over and over again. These three concepts can best be explained with a bullseye illustration. We have four combinations of low and high levels of precision and accuracy. This is what a tool with low precision and low accuracy looks like. The arrows don't land in the center of the target and they aren't clustered. This is what it looks like with low precision and high accuracy. The arrows are close to the center target, but they're not tightly packed together. In contrast, this is a pattern for low accuracy but high precision. The arrows are far from the target but clustered together. And lastly, this is what highly accurate and highly precise results look like. The arrows are on target and closely clustered together. Reliability is the ability to replicate the results over and over again. So while these results are not reliable at all, these ones that produce the same results over several tests are reliable. For my testing, I measured precision only as it's the most relevant for our purpose. It's also the easiest to test for. I don't view accuracy as all that important when it comes to wheel balancing and truing because it's the difference or precision in spoke tension among all the spokes that is most important, not the absolute tension of all the spokes. Also, if you calibrate your spoke tension meter as I suggest and don't rely on standard conversion charts, your tension meter will always be accurate because you're calibrating it to replicate the true amount of tension for each spoke type you're using. I also didn't test for reliability as I simply didn't have the time. To do this properly, I'd have to repeat the test over a period of months or years to get long-term results from each of the spoke tension meters. This is how I structured my test. I took tension deflection measurements over 3 rounds. The first at 110 kilograms of force, the 7 at 90 kgf, and the third at 65. For each of the 3 rounds, I took 5 tension readings with 1 tension meter and then moved on to the next 2. I then repeated this process over again so that I ended up with a total of 10 spoke tension readings for each spoke tension meter. I then repeated this entire process at a reduced calibrated spoke tension of 90 kilograms of force. Once done, I repeated the process one last time at 65 kgf. The reason I wanted to test the tension meters at high, medium, and low spoke tensions is because a lot of the poor quality tension meters struggle at providing accurate readings across a range of tensions, especially at the low end. I also chose to switch over to the next spoke tension meter after taking 5 readings to try to introduce a bit of reliability testing into the equation. I know this doesn't extend the time period of testing very much, but it's better than nothing. Before starting my test, I decided to mark the midpoint of the spoke with a white marker. This will allow me to position each tension meter tool exactly in the same place and will add consistency to my testing. My experience is that taking a tension measurement slightly above or below the midpoint really doesn't impact the reading, but there's no harm in being consistent, so I'll do it anyway. My first test of the 3-spoke meters is at 100 kilograms of force, so I calibrated my jig to replicate that amount of force. By slowly twisting the knob at the end of the jig, I'm able to increase the tension on the spoke in small increments. By the way, if you're wondering why I'm wearing a glove, it just gives me a better grip on the tension adjustment knob. So I keep turning the knob until I reach 110 kilograms of force. I try to get it as close as possible, but any deviation less than plus or minus 1 kgf is more than sufficient. Starting with my spoke tension calibration jig set to 110 kgf, I went about taking 5 tension readings with a Park Tool TM-1. I simply clamped the spoke meter onto the spoke, took the reading I was getting off the gauge, and entered the value into the spreadsheet. I did this for each of the first 5 spokes. After the 5th spoke reading was taken, I swapped over to the ZTTO meter and did the same thing. I clamped the spoke meter onto the spoke, noted the reading off the gauge, and entered the value into my spreadsheet. Again, after 5 spoke readings, I swapped over to Wheel Fanatyk Tensiometer and recorded my 5 readings for it. I now did my second pass at recording 5 spoke tension readings for each of my 3 tension meters. Again, I took my time to make sure I didn't make a mistake entering the values into the spreadsheet. And that was it. That was one of the 3 rounds completed. I recalibrated my spoke tension calibration jig to 90 kgf and followed the same sequence. And with the 90 kgf test done, I recalibrated the jig to 65 kilograms of force and did one final sequence of the testing. Now time for the reveal. How did these 3 tension meters compare? I've used 3 formulas in my spreadsheet to make it easier to objectively measure the level of precision of each. I calculated the standard deviation, which is a statistical measure of the dispersion of the dataset from its mean. I calculated the mean, which is simply the average force produced in the spoke testing. And lastly, I calculated the coefficient of variation, which is simply the ratio of standard deviation to mean. This is the formula I will use to determine which tool performed the best, because it allows for direct comparison where the mean of the datasets differ, which is exactly the situation I have here. And what you see in the results is pretty much what I expected. At all 3 tested spoke tensions, 110, 90, and 65 kilograms of force, the Wheel Fanatyk Tensiometer was the most precise, followed by the ZTTO TC02, with the Park Tool coming in last place. The Wheel Fanatyk Tensiometer was ridiculously precise, with a coefficient of variation of 0.0% at both the 110 and 65 kgf tests. and it was nearly perfect with just 0.1% variation recorded for the 90 kgf test. To put this into perspective, of the 30 spoke tensions measured with the Wheel Fanatyk Tensiometer, only one returned a spoke tension value different than its peers. And even so, it was off by only 0.01 millimeters. That is one precise tool. But even the ZTTO tensiometer performed very well in all the tests. And while the Park tool was a distant third in my test, it did much better than I expected. And while personally I'd want my spoke tensiometer to have less than plus or minus 1% of error, for most home mechanics the Park tool will be perfectly acceptable. I hope all of you found this test helpful. It's one I've wanted to do for quite some time, as I've never seen a test of these tension meters to see how precise they truly are. Let me know in the comment section below what you think of these 3 tensiometers or any other spoke tension meters you've tried. As for which one I'd recommend, that's pretty simple. You won't find a more precise spoke tension meter than the one produced by Wheel Fanatyk. It's incredibly well built and ridiculously precise. But the ZTTO TC02 is also a very capable measurement tool and a good choice if on a tight budget. I do not recommend the Park Tool TM-1 as the ZTTO performs better and is less expensive. My only caveat is that if you want a pre-made spoke deflection to spoke tension conversion chart, then the Park tool may be a good option for you. But you already know what I think of pre-made conversion charts. Go and make yourself a calibration jig. That's all I got for today, folks. If you like this video, please give me a thumbs up and share it with your friends. And if you're not a subscriber to this channel, please subscribe as allow me to produce more content for all of you. See you next time. Happy rolling.